to perform the next step in our program, which is assigning amino acids to the individual codons, we use a new data type, and this is again a very important way of structuring and keeping and maintaining data, which is Python dictionaries. And I think matching codons with amino acids is a great example to explain this data type, and it will come very handy to execute our program and achieve what we want to achieve here. So the idea is that in the initial step is that we want to generate the open reading frame. So we find our first ATG as we did before, and then we can say, okay, we found our sequence, and now we check is the codon 3 nucleotides long, and if it is, then we add this to the ORF. The ORF is initially defined as an empty string, so now this will step by step adding codons, so triplets of nucleotides to this ORF. This will grow as this for loop runs, and then we also need to check is there a stop codon. So now we need a database, a dictionary, which has all the codons, and we check is the codon that we are working with at the moment, so a nucleotide sequence like ATG or TAG or TAA, is that a stop codon or not? So we are checking that using a dictionary operation. And so for that, we need to understand dictionaries. If it is, then we stop the program and we return the open reading frame. And then in the next step, we can use again our codon table dictionary to perform the complete translation and generate the final result, which is the amino acid sequence we were looking for. So let's dive a little bit deeper into dictionaries. There's a lot to say about dictionaries, and they will come back again and again. I will give you a brief introduction and then again a notebook to explore a lot more by yourself with hands-on practice. So the fundamental syntax of defining a dictionary is you use these curly brackets, and you have always two pairs, a key, in our case the codon, and a value that is assigned to that key, which is in our case an amino acid. So ATG is methionine, and TAA is stop codon, TTT is a phenylalanine, and so on. So let's run this, and that will give us the dictionary printed out. It's good practice to keep it in this format, to have this aligned here vertically. It's easier to read. You can also just write the dictionary out like that. That would work as well. So if we change that and write it out in a straight line, that's perfectly valid. But when you have larger collection of data, it becomes much easier to read like that. So keys can be not anything. It's a little bit complicated, but most often they are either numbers or strings, and then they are followed by a colon here again, which is by a semicolon again, which is assigning them to a separate value. And you always have these key value pairs. The value again, this can be a list, this could be another dictionary, then it gets quite complicated. In our case, it's very simple. We have a string as key and a string as value. Right, so the first thing you want to do is how do I pull data out? And this is relatively easy. You say then you have bound this dictionary to a variable codon table, and we can say, okay, for the dictionary codon table, what is the value for ATG, for the key ATG? So we use this square bracket syntax here, put the value into the square brackets, and that will return us the key. That's a simple way of getting the keys out. So you can also get all the keys using the keyword. So codon table.keys will give you all the keys. Codon table.values will give you all the values here. And finally, we can also loop through the dictionary and get both key and value using items. So we can say for codon amino acid in codon table.items, and this is a function. So we have these brackets here, and then we print an F string codon amino acid. This is a little bit more complicated, so play around with this and get your head around it to understand what's going on here. Okay? Um, there are many ways of manipulating dictionaries. They're so fundamental, so there's quite a lot of effort to make working with dictionary easy. Um, and so one important way of interacting with dictionaries is you can add stuff. So you can say, for example, simply defining a new key value pair with a variable codon table in square brackets the new key, and then you say equals the value. Or we can change things. We could, for example, say a now should be start. So then we won't grow this in size, but we will change it. So you see a now has become start. Um, but yeah, this is quite intuitive, I think. There are other ways of getting values out. Get is an elegant way. So when you, for example, when you say give me a value that is not there, so for example, print codon table xxx, which is definitely not in the codon table, I will get an error. But sometimes I'm not sure if this is there or not, and I want to check, but I don't want the program to fail if it's not there. So get is a better way of performing this operation that we've just done here with square brackets. It does the same thing, but if it fails, so here, for example, if we say dot get, and this is a function, so we use these normal brackets. So then it will just not do anything. It just gives us none, which means no, it's not there, but the program doesn't fail. That's the difference between using the square bracket way of doing it or using get. And pop just gives us the last one, and it actually removes it from the dictionary. So it pops it out and puts it into a new variable. This is sometimes quite useful. There are many ways of dealing with dictionaries, and this is again something you can't learn from 5 minutes listening to a YouTube video, me talking and showing some stuff. So practice creating dictionaries, looping through dictionaries, accessing the values with the items, string, items, key, value, keywords, and methods, and also modifying and operating safely. And then there's some functions and challenges here for you. So I would again encourage you. This lecture has less notebooks, but the notebooks are a bit more intense. So I would really, I think if you go through this carefully and you also do the data camp lectures and data camp exercises, you'll become pros in no time dealing with dictionaries. Right, let's go now to finally the actual function that we want to use. So now you should understand the whole thing. So we are generating we're starting with an empty string, open reading frame. Then we're going through our DNA sequence. If we find the first ATG, we add the codon to the auth. So this auth will grow. If we say here now, for example, oops, if we say here print auth, it will show us how this grows over time. Let's just get rid of the rest here so that this is simpler. So you see how this for loop works by iterating, finding the ATG, finding the next one, finding the next codon, until this condition here becomes true, where the codon is a star, which in our case here TAA gives us a star where it stops. Okay. We defined a sequence that is actually, there's quite a few more things to go at the end, but the program works and it just gives us the actual codons until the stop. Great. So this is the first step in this function. Now the next step will be to translate. And again, we use our dictionary here. So as we use this, now this function returns the full open reading frame. And now we have a new function that takes this open reading frame as an argument, and then it does the same thing again. It gets each codon, and now it looks the codons up in the codon table, and it prints out the codon. Here we could do some checks and make sure that this, we're not getting any errors if the codon is not in the table and things like that. But for now, we keep it very simple. So let's run this, and it gives us a nice long ORF, and then a nice amino acid sequence with a stop codon at the end. So it does that by going into the dictionary, checking what is the amino acid for my specific codon at this particular time, and then adding the codon to the protein. So I hope this is clear and understandable. And if it's not clear and understandable, we'll go through this again in the labs and make sure that you understand this. And I hope that the DataCamp support and also the notebooks that we supplied will help you go through this by yourself. From me explaining this is getting a little bit complex, but you will be able to understand this. This is not too difficult in the end.